Hello, here's day 2 of the 10-7 note, so 10-7B. The very first slide here, I have a warm-up problem for you guys to complete. The question is, find the inverse of this function, and what I would like for you to try to do is find the inverse using a table and also find the inverse algebraically. I wrote the steps up there for algebraic. You have to switch the x's and y's and then you solve for y. Pause this video, take a few minutes to try this on your own, and then come back and check your answers. Alright, so here's my work, and I want to talk through a few of the steps. First off, using a table, I created a table for this function by just plugging in values of x. I chose 0, 1, 2, and 3, but really you could pick anything you wanted. Then I switch my x's and my y's in order to get the inverse. So I literally just flip the table around. In order to find the function of the inverse, remember we are working in this example with mx plus b, m being my slope and b being my y-intercept. My slope I need to find by doing rise over run. So I noticed in my table my y's were going up by 1 and my x's were going up by 2, which is why I got 1/4 as my slope. The y-intercept was a little bit trickier because I don't have an x equals 0, so I had to think backwards. Now, if I go backwards and subtract 4, that actually gives me a -2 for my x. So my y-intercept is halfway in between there. If I go backwards 1 here, I get if I go backwards 1, I end up getting -1. So I needed to find the place in between there where x would be 0. So, and in between 0 and -1 would be -1/2. So that's how I got my y-intercept. That's a little bit trickier because you didn't just happen to find x equals 0. For algebraic, I started with my equation, and then I switched my x's and my y's, and then I went through the solving process in order to get y by itself. A couple things to mention. One, this is an answer. The inverse is x minus 2 divided by 4, but if we wanted it to look like something that was in mx plus b form, I would first imagine that I have a 1 on top or next to that x. Then I'm going to do that double division that we've talked about before, where I would take that 1x divided by 4, oopsies, that would be one part of my double division. And then my other part would be doing the -2 divided by 4. All right, now again, this would be just another way to write the same thing, but I can also do a little bit of reducing and a little bit of, just rearranging of things. Instead of putting the x on the top, I could just put the x next to it so it looks more like my slope and my x. And then 2/4 is the same thing as writing 1/2. So we end up getting the same equation. Again, all of these I would accept as possible answers. We're going to continue finding inverses, but we're going to solve something that's not necessarily a line. So we're going to do this algebraically, and I have the steps, same steps I had before. But this time, if you notice, our equation is a quadratic, so things change just slightly. So instead of having f of x, what I'm going to do is I'm going to write it as y equals 3x squared plus 2. Okay, so that's what step 1 is. Just change the f of x into a y. It's easier. The second step is I'm going to rewrite everything exactly the same, except for, like yesterday, I am going to switch my x's and my y's. Okay? Now, just like yesterday, my third step is to solve for y, but this doesn't necessarily come as easily this time because we have that squared thing happening here. So we're going to still do the same process. I'm going to try to get the y by itself, and I'm going to subtract 2 to start with. Now, much like we did last unit, if I have a 3 in front of the y squared, I want to get that away and gone, so I am still working on getting the y squared by itself. Okay, now just like in this last problem, we could leave this as one big fraction, or if you would rather split it up like we did before, you could, but I still have not gotten y by itself. Remember from topic 9, the way we undo a square root or the opposite, or sorry, a square. The opposite of squaring something is square rooting it. So I need to square root both sides, and then the squared will cancel with that. So what that leaves me with, and I'm going to flip it around a little bit, is now I'm just left with y, and then on the other side I am left with x minus 2 divided by 3. Using the proper notation, we would have that inverse symbol, f to the negative 1 of x equals the square root of x minus 2 divided by 3. So this is an acceptable answer. Another way you could write it, or there's multiple ways you could write it, so I'm not going to do this for every single one, but just note that you could split up the square roots so you have one on top and one on the bottom, or you could do that double division like we talked about in the warm-up problem, where you write it as 1/3 x minus 2/3, and all of that is underneath the square root. Just note that everything is underneath the square root, not just the top, not just the bottom, not just the x, but everything is underneath the square root. Okay, me personally, because it's less work, I would probably type in this top option, but again, all of them are acceptable. Now I'd like for you to try one. I want you to find the inverse of this quadratic function, f of x equals 6x squared, algebraically. Pause the video, try it on your own, and then come back and check your answers when you are done. And we are back. The answer that I ended up getting was that the inverse of that function is the square root of x divided by 6. Now below that, in the two other black writings, I have the square root of x over the square root of 6 or the square root of 1/6 x. All of those are exactly the same, and all of those would be acceptable. However, the top one requires me to do the least amount of work. Now, if you're confused on the process, the very first thing I did, step 1, is I wrote it as a y instead of an f of x. Then in step 2, I switched my x's and my y's, and then I started solving for y. There wasn't anything adding or subtracting this time, so I divided by 6 on both sides, and then I took the square root in order to cancel out the squared, and that's what left me with the square root of x divided by 6. You might be saying to yourself, or saying to me via the video, why do we need to know about inverse functions, Ms. Krupstad? What do inverse functions even mean? This is best demonstrated using a word problem or an application problem. So we have Grace, she's a coach, she's ordering swimsuits for $37 each, plus $6.99 for the shipping and handling. The first thing they want us to do is write a function that represents the cost in dollars of ordering X suits. Then they want us to write an inverse function, and then we'll talk about what the inverse function actually represents. So the very first thing we are going to do is write a function. All right, I'm going to use x's and y's, but you could use different variables if you wanted to. I am going to say that my y is my cost, so the total amount of money that we're spending on this stuff, and x is how many suits we are ordering. If you've done any online shopping, which I may or may not have done a lot of during this time we have been home, you usually are paying for the number of items that you purchase, and then there's generally a flat fee for shipping and handling. So this is going to represent like a linear situation, all right? Like if you remember our line, we've done this in the past, mx plus b. B is going to represent that flat rate, okay? It is the flat, I shouldn't even use the word rate. It is a flat cost, okay, that we are doing. It doesn't change. It's called the constant. Oh, I can't write. Constant. Okay, the thing that's not changing. M is our slope, and this is the thing that changes. So this is our, like the rate or the cost of suits, the thing that depends on how many we are ordering. So when we write this equation, our cost is $37 for every suit, but then I have that constant fee, that shipping and handling fee of $6.99 for every order, or like for the order that I place. Okay, so the shipping and handling isn't going to change for every suit. All right, so that would be the equation that we came up with. Now, we want to find the inverse of the function. And the reason we want to find the inverse is because the question is, how many suits can the coach order if she has $913 to spend? Well, this $913 is how much I can have as my cost. Now, we could plug that into the equation and then solve for y. That would be one option, but another option is to find the inverse. So what we're going to do, just like we did before, is we are going to switch our x's and our y's. Everything else remains the same. Now I am going to solve for y. So I'm going to subtract 699. All right, and then I'm going to divide by 37 in order to get the y by itself. So I'm going to rewrite that a little bit nicer. I'm going to write y equals x minus 699 divided by 37. What we do when we make an inverse function is we switch what our variables are. So what I have now done is I have said that my y now represents how many suits I'm buying, and my x represents the cost. This is great if you are going to be using this same equation multiple times in kind of the reverse order. So what we can now do, since our x is our cost and our y is our suits, is if I know my cost is $913, I can plug that in for x and solve for y. I ended up getting 24.5 suits, but we obviously aren't going to have a fraction amount of suits, so I would probably say about 24 suits. You might pay attention to what Pearson is suggesting as to whether they are asking you to round up or round down, so it could also potentially be 25 suits, depending upon how they ask you to round. So again, you could have done this same thing by plugging in 913 into your original equation, but the reason why inverse functions are so awesome is that if I change now my cost, maybe next year I'm buying another set of suits for my team, but now I only have $800 to spend. Instead of having to plug it in and resolve, now I could use this new inverse equation and find the number of suits. So inverse functions can be really beneficial, especially when you're doing something multiple times. The last two examples are having to do with formulas for area or surface area or perimeter or any of those such things. These are slightly different because the A and the S represent very particular things here. So it's asking us, the equation for the area of a cube is A equals 6S squared, where S is the side length of the cube and A represents the area. Write this equation as the inverse, where S equals blank. All right, so normally our very first step would be to switch the variables. We are not going to switch the variables when we are dealing with a formula because I do not want area to represent the side length or the A to represent the side length, and I do not want the S to represent the area. That's too confusing if we're using these specific variables. All that we are going to do is we are going to rewrite this equation as S equals. So when you have a formula, do not switch the variables. Okay, we do not want to change what those variables represent, like in the last problem. Okay, so just like in the problems prior, I need to get S by itself, so I'm going to divide both sides by 6. So if A divided by 6 equals S squared, in order to get rid of that squared, I need to take the square root. So I am left with the square root of A divided by 6 equals S. Okay, or I will write it as S equals the square root of A divided by 6, where everything is underneath the square root. What's nice about having it like this is now if I know what the area is, I can easily plug that number in order to find the side length. So if I knew I wanted my cube to have an area of 36, all I would need to do is plug in the 36, and then I would be able to find that my side length is the square root of 6. Let's have you guys try one on your own. The equation for distance in meters for a free-falling object is d equals 5t squared. Find the equation for the inverse. What does t equal? So you need to take this equation and solve it for t. Pause the video, try it on your own, and then come back and check your answer. My final answer to this was the t, or the time, equals the square root of the distance divided by 5, or d divided by 5. How I did that was I just divided both sides by 5 and then took the square root. And as a reminder, if you're dealing with a formula, you will not switch the variables because you do not want to change what their meaning is. That's it for 10.7b. Here's a quick summary of what you talked about in 10.7. In order to use a table to find an inverse, you switch the x and y columns. When you're graphing, it looks like it flips over that dotted line, y equals x, because what we're doing is switching the x's and y's. And then to find the equation of an inverse algebraically, you switch the x's and y's and solve for y. Please let us know if you have any questions. I hope you have a great day.